So at this point right here, since we learned that sine and cosines are all functions, right? So you got a function f of x right here, being a sine of x is a function. And then also the same with you can also define a function f of x to be a function cosine of x. Okay. And so I want you to evaluate this. So think about how about I'm going to pick an angle, sine of pi over 6. Okay. So f of pi over 6 here in this column, it means I'm looking for sine of the angle pi over 6, right? Right. And then at the same time, how about for this on this column right here, f of pi over 6 again. Okay. But that means a cosine of pi over 6. Two separate functions, even though I named them the same over here. But my question now is that, yeah, go ahead and have the value for the sine of pi over 6, and then at the same time the cosine of pi over 6. Okay. Thank you. 1/2. What about cosine of pi over 6? Anyone? Root 3 over 2. Right? So we've got a value over here. So that's output. That's input. This is output. That's input. Right? So now. But on the other hand, I want to also do another extra one, and this is probably something that everybody is still not so comfortable yet, but we will get there. So what about sine of minus pi over 6? So I stay with the exact same angle, but I want a negative this time. See what I mean? Okay. So in other words, this means I'm looking at defining sine as a function. I'm talking about f of minus pi over 6, right? Same inputs, but being the opposite. See what I mean? And then I plan to do the same thing for the cosine. So cosine, so from the pi over 6 angle, I want to look at the negative pi over 6 angle here. Right? So take a minute to calculate that value right there, to locate that value from the unit circle, or to calculate that value with that.
Negative 1/2.
Negative 1/2. Right. Negative 1/2. Right. What about this? Case here, cosine of the negative angle. So root 3 over 2 is positive, right? See what I mean? Right. So now we want to make some conclusions out of what we were just now doing here. Now, from what I was doing, let's put these information together right here. The work that we've just done here, I'm putting that in a box, right? And the work we're just doing here, putting that in a box. So let me now point out. You see, the observation sine of pi over 6, we found the output to be a positive 1/2, right? Sine of negative pi over 6, right? Same angle, but just the opposite input right there. That's the opposite sign right there. Now, the output for this was a negative 1/2, right? Negative 1/2. The negative 1/2 that we found right here is the negative answer of this sine of pi over 6. You guys see what I'm saying there? Because sine of pi over 6 itself is a positive 1/2, and sine of minus pi over 6, right, is a negative 1/2. So the relationship now we can conclude together. The relationship now I found is that for the sine function, taking a negative input, okay, it's always going to be the negative of the same function, but on a positive input. Okay. That's the relationship that we've found. See, this came out negative 1/2, right? And this just sine of pi over 6 itself is a positive 1/2, but now we're putting a negative sign to that, right? The two answers agree. Well, so in that way, we formulate this important understanding right here. For your sine of x, right? That f of x, or how about f of theta, right? It doesn't matter what input number is, but I've been using x for long enough, so I switch to theta here. So sine of theta equals, f of theta equals sine of theta. Function f defined as a sine function. And this is what we know right here. Sine of, see, putting in a negative angle, right? Negative input right here. And of course here, let's assume that the angle itself is a positive angle. So putting in a negative angle, the answer will come out being the same as that sine value of the positive angle. We flip the sign of that final output. You guys follow with that, right? Okay. This is also an important relationship that we have found just now through investigation throughout calculating value right there. So in this case right here, here's the way how I'm seeing it. Generally, if your function here sine is your function f, right? So that means more generally we're talking about for your sine function, we're looking at the f of the negative inputs, right? Equal to the minus of the function being positive input. So in this way right here, we recognize from pre-calculus 1, this relationship right here implies that your sine function, right? Sine of theta, your function here, because this is when you're looking at this means your function f of theta is an odd function. Okay. So from this case, you can say that sine of theta, this sine function is also an odd function. Okay. That's one highlighted piece of information that we're looking at. Now back on this board right here, the cosine value that we have found out earlier, there's a positive input and there's the exact same function but taking at the negative input like that. So putting it side by side, I can see that cosine of the negative input is related to the same function cosine of the positive input. With what relation? They are exactly equal. Right? See, these two right here, putting it together, cosine of negative inputs is exactly the same as the cosine of the positive inputs as well. Right? So drawing out from this relationship, from this observation right here, I'm seeing that. On the other hand, right, if we define some function f of theta equals cosine of theta, and for theta being, assuming that theta is just always a positive angle, then what we generally for cosine of the negative input is exactly the same as just equal to the cosine of the positive input itself as well. Okay. This is one thing that we drew out as a conclusion for the cosine function. But that generally means that this implies a further observation that hey, for our function, this case here, we fell right into that case where the function evaluated at the negative input equals the function at the positive input itself as well. And so from those observations, we can make a conclusion that from our passive understanding from the pre-calculus 1, then we can see that f of x is f of theta in this case is an even function. And then in case this understanding is not in case this understanding has faded from you right there, then that's okay. Right here, this is also the way how we define what it means by having a function being an even function and then having a function being an odd function. Okay? Even if you may have not seen that back in your pre-calculus 1. It should have been taught in pre-calculus 1, but in case you don't remember or in case it was not formally mentioned, then that's how it is. So that means cosine of theta is even. There are many even functions out there, and cosine is one of them. It's an even function. Also go back to this and say cosine of theta is an odd function. So those highlighted information is important for us to understand. These lines here sort of like we recall some past understanding. In case you haven't seen that in your past courses, we can also treat it as some further information that now deserves your attention. And now we're in the middle of talking about the graphs of these functions. We already talked about the graphs of these sine and cosine functions, right? So what does even and odd have to do with the graph? So here's the thing. Now, generally speaking, for an even function, when you see the graph has to be, if you see the graph of an even function has to be symmetry. through the y-axis. So there's a y-axis right here. Then the graph of an even function has to generally be symmetric, like that. Okay. There are two, like the y-axis here is being a mirror, right? And the two pieces, the graph, are being symmetric right through the y-axis. That's the property, the graphical property of an even function, in general. For any graph of an odd function, then the graph, say you got a piece here, then you're going to have a symmetric piece, but only symmetric through the origin. Right? So for odd function, the graph is symmetric through through that origin. The graph, when it's an even function, the graph, the y-axis. Okay? And of course, again, I'm not saying that this graph I'm drawing here is the graph for our cosine function. I'm just saying that in general, anytime you're looking at it, an even function, right? The graph of it, an even function will reflect through the y-axis. Okay? And then the graph for any odd function, right, will reflect through that origin. So every point on one side here of the origin, right, has an exact mirror reflection through the other side, through the origin. Right? So that's a general property of being an even or being an odd function. Right. Now let me bring that in to the illustration with the graph right here for sine and cosine of x, as you guys can see. Okay, so this is the graph for sine of x, right? At least I put that down in that one rotation right there. Okay, so it's the graph of your sine of x function. See what I'm saying now? But the graph, the portion of the sine of x function here I'm showing on the screen is starting at 0 and ending at 2 pi, right? So we've got an end point right there. You guys with me on that? Okay, right on that side of that, right? But this time, since we're talking about, and let me redefine this a little bit. Let me call that some f of x, right, equals sine of x. Okay, so now let's leave the cosine out for now. I'm going to show the window where the graph of sine of x is just anywhere from, like, showing so that the origin is right in the middle like that. So now let me show you the calculation result we have done earlier. Now, at pi over 6, right, didn't we have a point at sine of pi over 6? So this was that point. This is sine. So pi over 6 for the angle, sine of pi over 6 is height. That's why we have that point that stays right on the graph itself, right? You guys read that? Right. And then, but then for the minus pi over 6, the angle now is negative, right? Opposite angle, see, here it was positive inputs, here it's negative inputs. I go with sine of negative pi over 6. Let me put that point in the same column with the other point. Okay. You see how these points are exactly symmetric. Okay? They are a reflection of each other through the origin. And that's what I was trying to point out earlier. So once again, the graph here for sine of x, right, convinces us that this function sine of x here is an odd function right there. Because every point is, I think, 5 or 6, right? 5 or 6 has a point right there on the graph. And it has the exact mirror reflection, right, but only through the origin. So the origin is the mirror, right? And that it has another guy that's perfectly symmetric to that origin. Okay. See what I'm trying to demonstrate. Okay? And then I can bring in another point. I can bring in another one right here. Let's say I can put in like a, here's make it even more trivial, like a pi over 3 here, right? Okay, so pi over 3 lands right into that point of this. So this is pi over 3, but that point itself is pi over 3 comma the sine of pi over 3, right? So for the other point right there, I'm going to move it out to negative pi over 3. Right? And I'm taking sine value of negative pi over 3. See how that point pops out like that? Okay. So that's how it is, that these 2 points are exactly symmetric through each other. I mean through the origin right there. Right? That point right here, right, has an exact mirror reflection through the origin right down there. And that's why, once again, that it's consistent with what we've learned. It's showing what we've learned, that the graph for an odd function, right, is symmetric through the origin. Right? And so, what about a cosine function? So the graph of cosine, see, when I'm putting that right center at the y-axis, here the origin is right in the middle of the screen right here. The graph of cosine looks like this in that part. So this is pi over 3 and cosine of pi over 3. You have that point, right? And then negative inputs gives me and cosine of negative pi over 3. So you see how these 2 points, they are exact mirror reflection through the y-axis, like that. Okay, so in this case, and the whole graph itself, you can see that there's a mirror here, right? And everything on the right-hand side has the exact reflection on the left-hand side of that through the vertical axis. And so that's the graphical property of being an even function. So cosine itself, right? The graph agrees perfectly with what we have just proven mathematically, that it's an even function. Okay. But then so looking at the graph here for even and for odd is one way. What's important here, I want you guys to emphasize, is that we have this relationship, right? Sine of the negative input, right? It just simply be equal to take sine of the usual positive inputs and then put the negative sign at the end. So we'll find our answer. And then the same way here, when you take cosine of a negative input, right, that the answer comes out to simply be the same as cosine of the usual positive input, as we're familiar with. Okay? So after doing all that, we're ready to do some more with your sine and cosine function.